Hello everyone, I am S. Chandrapavan of CSE AI. Today, I am going to explain the topic quicksort and its time complexity. In computer science, sorting is an essential operation. The quicksort algorithm is efficient and popular for its speed. Let's dive deep into understanding the quicksort and its time complexity. Overview of quicksort algorithm. There are three algorithms: divide and conquer, recursive, repeat. First, divide and conquer. Quicksort is a divide and conquer algorithm. It picks an element as the pivot and partitions the given array around the chosen pivot. Recursive. It is a recursive algorithm where subarrays are sorted separately. The subarrays are divided into two subarrays, the left and right. Next, repeat. This process repeats until all subarrays are sorted. Algorithm for quicksort. Algorithm. Quicksort of A of L to R. If L less than R, S equal to partition. A of less to R, quicksort of A of L to S minus 1. Quicksort of A comma S plus 1 to R. Partition. Partition of A of L to R. Pivot equal to A of L. Then I equal to I plus 1. J equal to R. Repeat. Repeat I equal to I plus 1 until A of I greater than or equal to P. Repeat J equal to J plus 1 until A of J less than or equal to P. Swap A of I comma A of J until I greater than or equal to j. Swap a of I comma a of j. Again swap a of I comma a of j. Return j. Picking the pivot element. The pivot element can have a huge impact on performance. That's why one needs to be selected carefully. There are several techniques to choose a pivot element, including first or last element. Select the first or last element in the array as a pivot. Random element. Randomly select an element from the array as a pivot element. Median of 3. Choose the median value from the first, middle, and last elements in the array as a pivot element. Example on quicksort algorithm. Now let's see the working of quicksort algorithm. To understand the working of quicksort, let's take an unsorted array. It will make the concept more clear and understandable. Let the elements of array are 24, 9, 29, 14, 19, 27. In the given array, we consider the leftmost element as pivot. So in this case, A of left equal to 24, A of right equal to 27, A of pivot equal to 24. Now A of pivot less than A of right moves forward from one position to towards left. Okay. Now this uh, now A of left equal 24, A of right equal 19, A of pivot equal 24. Because A of pivot greater than A of 19. So algorithm will swap A of pivot with a right and pivot moves to right as. Now A of left equal to 19, A of right equal to 24 and pivot is 24. Since pivot is at right, so algorithm starts from left and moves towards right. So algorithm moves from left to right. So 9. So now A of left equal to 9 and A of right equal to 24 as pivot is also 24. So pivot is greater than A of left. So algorithm moves from one position to another. A of left is 29, A of right is 24, and A of pivot is 24. As a pivot less than A of left. So swap a pivot and a left. Now pivot is at left. Now next one. A of pivot equal 24 and A of left equal 24 and A of right is 29. Sorry, it's mistake. A of right is 24. As a pivot greater than A of right. So swap a pivot and A of right. Now pivot is at right. Now A of pivot equal 24 and A of left equal 14. Uh, Pivot is at right. So the algorithm starts from left and moves towards right. Now a pivot is at 24 and A of left is 24. A of right is also 24. So pivot left and right are pointing the same element. It represents the termination of procedure. Element 24, which is the pivot element, is placed at its exact position. Elements that are right side of element 24 are greater than it, and the elements that are left side of the element 24 are smaller than it. Uh, and A of pivot is 24, and A of left also 24, A of right also 24. So elements from right side of the uh, elements that are right side of element 24 are greater than it, and lesser than 24 are lesser or smaller. So these are left subarrays and these are right subarrays. Now, in a similar manner, quicksort algorithm is separately applied to the left and right subarray. After sorting it's done, the array will be like this. Time complexity. There are three cases in time complexity: best case complexity, average case complexity, worst case complexity. Best case complexity. When the partitioning algorithm always chooses the middle element or near the middle element as the pivot, the best case scenario happens. Quicksort's best case time complexity is big O of n into log n. The following is the best case recurrence. T of n equal to 2t of n by 2 plus big O of n. Solution big O of n log n. Second, average case complexity. This occurs when the array element are in a disordered sequence that isn't increasing or decreasing properly. Quicksort's average case time complexity is big O of n into log n. The following is the average case recurrence. T of n equal to T of n by n plus T of 9n by 10 plus big O of n. Solution big O of n log n. Third, worst case complexity. The worst case situation is when the partitioning algorithm picks the largest or smallest element as the pivot element every time. The worst case time complexity of quicksort is big O of n square. The following is the worst case recurrence. T of n equal to T of 0 plus T of n minus 1 plus big O of n. Solution big O of n square. Advantages and disadvantages of quicksort. Advantages are: first one of the fastest algorithm on average. Second, does not need additional memory. The sorting takes place in the array. This is called in-place processing. And the disadvantages of quicksort are: the worst case complexity is big O of n square. Conclusion: quicksort is a winner. In conclusion, quicksort is an efficient algorithm with an average time complexity of big O of n log n. It is quick and can sort vast amount of data and has been widely adopted into many programming languages. Thank you. Please like, share and subscribe to my channel. Bye.